Hi, I'm Dr. Chris Creighton, and in this video we'll be adding and subtracting radicals. We will be focusing on performing radical algebra, and particularly addition and subtraction of radicals. In order to do so, we'll need to be able to convert between fractional and radicals, fractional exponents and radicals, in order to simplify radicals, because that is the first step. So when can we add and subtract radicals? Well, the first thing, let's just compare some. How about the square root of 3 plus the square root of 3? Well, looking at that, it's 2 root 3's together, so that's just 2 square root of 3. But what about the square root of 3 plus the cube root of 3? Well, the first term here is the square root. The second term here is the cube root. Those things have different indices. And in these cases, we cannot add, because the indexes are different. Now, what if we had something like the square root of 3 plus the square root of 5? Even though the indexes are the same, they're both square roots, they have different radicands. So the radicands being the inside of the radicals. And in this case as well, we cannot add. All right, we can't add those together. There's no way of doing so. Because of the one at the start here, root 3 plus root 3, well, we just had one root 3 and another root 3. In this case, we have one square root of 3, one square root of 5. They're different. And the other one, we have a square root of 3 and the cube root of 3. And then for another example, we have 3 plus the square root of 12. Well, those ones have different radicands, but in this case here, comparing to the previous one, we can simplify that. So the square root of 12, that one can be written as 2 root 3. Now we're back in the original cases, and this is equal to 3 root 3. So the big difference here is comparing this to polynomials. We cannot add things like x squared plus x cubed. That's fully simplified. And that's sort of epitomized right there with the different indices. Those are fractional exponents. Likewise, we cannot add x squared plus like a y squared. Those are just completely different values. It is the same idea here. Now, if you can rewrite, like, say, the y, like we did with this 12, in terms of x, then we can add them. But in these cases here, we cannot add. So that highlights that case there. So what we say here is that we can add if they are like, and they have to have the same indices, same index, and same radicand. And again, that's the inside of the radical. So this is the key thing that we need in order to add or subtract them. So essentially, what to do to add and subtract. So the first step you should do is simplify all terms that are added or subtracted. And that is so that we can simplify these down. So like, for instance, the root 12 turns into a 2 root 3. And then we can add that to root 3. So once you simplify, you're going to be able to add or subtract them. And then you add or subtract like radicands. And in this case here, they need to be like in terms of same index and same radicand. So like, for instance, like in before, we can add root 2 plus 2 root 2. That's great. But we cannot add the cube root of 2 plus the square root of 3. Like, those things are just different indices and different radicands, so we cannot add those. All right, so we're going to be doing a bunch of indicated operations. So the instructions will be just do the indicated operations. So if it says add, you add. If it says subtract, you subtract. And we're going to assume all the variables are positive, just so we don't avoid, oh, that's not a real number. if we choose a value for x. We're going to do all the variables are positive. So for the first problem here, we're going to do 2 root 11 minus root 11 plus 3 root 44. So now going with our order of operations kind of here. It's not really order of operations, it's procedures. The first thing is we need to simplify each radicand. And the first thing I see here is that those root 11s, 11 is prime, those are completely factored. But this square root of 44, that is 11 times 4. So that can be equal to 2 root 11 minus root 11 plus 3 times the square root of 4 times 11, which simplifies to 2 root 11 minus root 11 plus 6 root 11. And that 6 comes from the square root of 4 times the 3. So the square root of 4 is 2, 2 times 3 is 6. Now, all of these things have the same index, 2. They're square roots. And they all have the same radicand, 11. So then we can add them. So this is equal to 2, coming from that one, minus 1, because we're subtracting there, plus 6 square root of 11, which is equal to 2 minus 1 is 1, plus 6, which is 7, square root of 11. Next, let's do another one. How about the square root of 12 minus the square root of 8 plus the square root of 27? So in this case here, none of the radicals are simplified, right? Because the 12 can factor, that's a 4 times 3. The 8 is a 4 times 2. And the 27 is 3 cubed. So this can be written as 2 root 3, going a little faster there, minus 2 root 2 plus 3 root 3. So those are simplifying the radicals. Now, we can only add the ones that have the same index. Now, they all are index 2. And the same radicands, the insides. The only ones we can actually add together are these two. Those ones are both the square root of 3. That root 2 cannot be added to a root 3. So the best we can hope for is this. So we have a 2 root 3 plus a 3 root 3 gives us a 2 plus 3 root 3 minus that 2 root 2, which is equal to 5 root 3 minus 2 root 2. And now this is fully simplified. This is the best we can hope for with adding. Each of the terms is written in terms of fully simplified radicals, and we added all the ones together that we can. Let's do a couple more. So I think that we're on 3. How about the 4th root of x to the 5th times y? So now this is where the assuming the variable is positive comes in, because if they weren't, that wouldn't be a real quantity, minus 2x, the 4th root of xy. Again, following our procedure, we note that the second term here, the 4th root of x times y, that's fully simplified. But the first one is that the x to the 5th can be simplified itself, being that it's inside the 4th root. So that can be written as the 4th root of x to the 4th times xy minus 2x, the 4th root of xy. And then this simplifies as x, the 4th root of xy, minus 2x times the 4th root of xy. So in this case here, we have two radicals. They're both of index 4, so they're both 4th roots. And the radicand is both x and y. So that in this case here, we can, in fact, subtract them. So to do so, I write x, coming from this x for the x4th root of x times y, minus 2x, coming from the second term, times the 4th root of xy. And that leaves us with the final answer of x minus 2x is just a minus x times the 4th root of xy. Now that is fully simplified, and that is them subtracted. Next, let's do 5 square root of 12y plus 6 square root of 75y. Again, we're going to assume y is positive. So in this case here, neither of these two radicals are simplified. They're both square roots, but I know that I can factor the 75 and I can factor the 12. So in this case here, the 12 is 4 times 3, so that simplifies as 5 times 2 square root of 3y plus 6 times 5, because 75 factors as 25, which is square root to 5, times 3. So that leaves us a 3y left over. And again, in this case here, both the indices of those are 2. That allows us to compare the radicands. They're both 3y. That means that we can add them. So simplifying a bit more, this is 10 square root of 3y plus 6 times 5 is 30 square root of 3y. And then adding, we get 10 plus 30 root 3y, which is equal to 40 square root of 3y as our final answer.